Hello, in this video I'm going to be introducing you to solving trig equations, and as this is just an introduction we're going to cover only basic examples like this one below where we need to solve sine of x equals 1/2 for values of x ranging between 0 and 360 degrees. If you want to see more complicated questions answered like sine of 5x equals root 2 over 2 between negative pi and positive pi, then you can go to the description where I'll link my video on that below. And so I think the best way to learn this is just to look at examples, so we'll start off with this question here. So we need to solve sine of x equals 1/2 for values of x ranging between 0 and 360 degrees. So what does this mean? Well, we need to find a value of x, okay, that is between 0 and 360 degrees such that if I substitute it in here, the output will be equal to 1/2. And so how do we do that? Well, I always like to sketch out the graph first. And so I'm going to sketch the graph of sine of x between the values of 0 and 360. And if I do that, it's going to look something like this. Okay, it doesn't have to be perfect, it can just be a sketch like that. And so now if I label up my x-axis, we're going to have 0, well this is 90, 180, 270 and 360 degrees. And we're going to have 1 and -1 as the values the graph is going between. So we want to know when this graph, okay, sine of x is equal to 1/2. Well, that's going to be on this point here. So if I draw in the line y equals 1/2, it's where they intersect. So it's going to be, well, this point here and also this point here. So how can I find those values of x that make that equal 1/2? Well, you might memorize the values of x such that sine of x equals 1/2. You might know a triangle, or you could just use a calculator and you could do, well, inverse sine of 1/2, and that would give you the value of x, which it gives out as 30 degrees, okay? And so that is obviously referring to this first solution here. So this solution here is going to be 30 degrees. So how can I use this then to find my second solution, this one over here on the right? Well, if I zoom in a bit, hopefully you can see that the graph is symmetrical, okay? Symmetrical along this line here between the values of 0 and 180. So like this part here, it's symmetrical. So we can use this to help us find the other solution. And we could say that, well, how far across from 0 do I have to go to get to this first solution? Well, I have to go across 30 degrees. And so by the symmetry, if I start at 180 and move back 30 degrees, that's going to take me to this second solution. And so I can just do 180 subtract 30, and that gives me an answer of 150. And so my two solutions are going to be x equals 30 degrees or x equals 150 degrees. And if you want to check these solutions, you can just put them into your calculator. So sine of 30, well, that will give you 1/2, and so will sine of 150. So it's actually pretty straightforward. Let's now look at a second example, okay? And in this one, we need to solve cos of x equals root 2 over 2 for values of x ranging between negative 360 degrees and positive 360 degrees. So again, when I'm solving this, I'm going to sketch the graph first. So I'm going to try and sketch the graph of cosine of x between negative and positive 360 degrees. And it's going to look something like this. I'll see if I can, that will do. Okay, and now I'm going to label up my x-axis. So we'll have 0, 90, 180, 270, 360, and then on this side the negatives. So 90, negative 180, negative 270, negative 360. And we want to know where this curve, or this graph, cosine of x equals root 2 over 2. Well, root 2 over 2, if I were to draw it on, it would be up here somewhere like this, okay? So this would be root 2 over 2. And so it's going to have 4 solutions. Hopefully you can see that. I'll circle them all, these 4 here. So how can I find my first one that will help me find the rest? Well, I'm again just going to do inverse cos of root 2 over 2. And if I just use my calculator and do inverse cos of root 2 divided by 2, it gives me an answer of 45 degrees. Okay, so I can now remember that. So this is going to be 45 degrees. And again, we're going to use symmetry to help us answer this. So let me zoom in. Hopefully between 0 and 360 degrees, you can see the graph is symmetrical at this point here. So if I'm moving across 45 degrees from 0 to take me to my solution, then I'm going to move backwards from 360 degrees by 45 to take me to my other solution. And so this one here is going to be, well, 360 subtract 45, so it's going to be 315 degrees. And now, again, because this is a symmetrical graph, I can say that, well, if I've gone forwards 45 degrees to get to this solution here, I could just go back from 0, 45 degrees, and so this solution here is going to be negative 45 degrees, okay? And I can apply the same logic to get this fourth solution, which is negative 315 degrees. Now that's not the only way you could have done it, okay? Once you've got these first two solutions, you could add or subtract 360 degrees to take you to each other solution. So for example, if I'm talking about this solution here, I'll circle it in black, and move back 360 degrees, well that's going to take me to this one. And if I start at this solution here, which is 315 degrees, and subtract 360, it's going to take me to this solution here. Okay, hopefully that makes sense. So that's pretty much it for this video. Hopefully it was useful. If it was, like, subscribe and share, and go over to my channel for tons more maths tutorials. Thanks for watching.